Okay, we're here with what I believe is supposed to be seniors honor statistics. Second period, we're talking about sample surveys. So, what we just got through doing was a mini activity about these jelly blubbers, and I was trying to show you many things, one of which I already told you was the fact that inherently humans are biased, which is why whenever you run any kind of sample survey, you want to incorporate randomization. Right? In this case, we use a very simple random number table, where every jelly blubber from 1 through 100 had a chance to be picked. All right? So, when we're thinking about our example, the population, in this case, was the 100 blubbers. And the sample you selected was those 10 blubbers. All right? Now, a lot of times when you're thinking about sampling, it's easiest to think about if you're ever cooking and you want to taste it to see if your food is ready to be eaten because it tastes good, right? As my in-laws would say, always add more salt. All right? It's just so much salt all the time. Anyway, what I always think of is when you're making like a big pot of soup, all right, and you want to taste a sample, you don't need a big ladle, just a tiny little bit will do. Okay? So it's always about the size of the sample when you're talking about sampling surveys. You're always thinking about the size of the sample. Okay? So this is something that you're going to see whether you go into stats or anything about in this type of world with sampling. You're going to see it. I mean, you're going to see it every 4 years with elections. All right? But polling and sampling is a big deal. It's a lot of money goes into this. So hopefully when you leave this course, you have a very general idea of what's happening when you read polls. Okay. Now bias. All right. We already proved you guys are biased towards those smaller blubbers. It's okay, blubbers. All right. And the best way to avoid this is to use randomization. All right. If you find out that a poll or a sampling method that you're reading about shows bias, you might as well just rip it up. All right, there's no way to come back from a biased sampling method. So we use randomness and random number tables. We view that as a positive in statistics. So in the blubbers, we overemphasized the larger blubbers. Our eyes were drawn to the fact that they're bigger, so we picked bigger ones on average.
So you use the same story
from Spain? From Spain. I've never been to Panama. Well, usually the story I give for the blubbers is over my honeymoon when we were in Costa Brava, and I was walking along the water. I spotted the blubbers. I snapped a photo, and that's the photo. But I figured you guys were too smart for that, so I changed the story. But you never can tell, right? Sometimes when I say things, they're true, but other times they're not.
You're a really good liar.
I don't think it's that. It's more of just like I want you to believe in the story, right? You want to believe in the truth of it, yes. Well, it's one of those things that if you were to see it in a movie, it would say based on real events, right? Was I in Madrid? Was I there at the parade? I was. Did I actually say hello to the king? No.
The king told you.
No, he didn't. Someday. Based on real events. Right? I was walking along the water at Costa Brava, but I didn't see any blubbers, sadly.
Maybe you didn't know you saw.
Maybe they were so small. I was being biased. Okay. So, randomization. Okay? The reason we use randomization with the blubbers is to make sure that we have a good representation out of those 100 blubbers. But what's really, I think, one of the more powerful things about randomization that as a student when I was learning this, I thought was really interesting is that randomization not only helps you avoid issues that you already can think of, right? I can think of the fact that I want to make sure that all of my blubbers are represented. But when you do randomization with other sampling, there might be things you haven't even thought of that randomization will help you avoid. Okay, so that's why it's key. If you are writing down how you're going to find and create a sample, if randomization is not a part of it, then you've got a problem. You should reevaluate and go back. Okay, the sample size. I already mentioned this, but the sample size, whenever you're thinking about a sample versus a population, it's always about the size of the sample. Remember my soup example. All right, think about a big pot that's going to feed my family. Okay? And when I sample it, I have this little tiny spoon that I taste it to see if it's ready to feed my family. Okay? What if instead of feeding my family, I wanted to feed all of you? So I have a bigger pot. Do I need a bigger sample spoon? No, right? The idea is that it's not the size of the population, it's the size of the sample. That's what matters. There is a caveat here, this exception. All right, this caveat here is important, but not yet, not until next semester, where we have to ask ourselves, is the sample more than 10% of the population? So that's something we'll bring back in the next semester. But right now, really you're just focused on the sample size. Now, you've probably heard this before because it came up in the news, I think a month or two ago, about the census, maybe more months ago, about the question that was trying to be put on the census. No, what was that question? Oh my gosh. It was like unconstitutional. Nobody remembers? Is that what the news? I mean, I don't remember. Yeah, they try to get a question on the census like, are you a citizen? I think that's what they wanted to put on there. Anyway, I'm pretty sure, I'll have to Google it, but I'm pretty sure that was tried to put on there, but it was not allowed. So the census happens usually every decade, where they go door to door and try to figure out how many people live in a certain area so they can allocate funds, all right, for that area, like state and federal funds. All right, so whenever you see the word census, you should think everyone is being asked. All right, so a census of this school is every student, every faculty, every staff member is being asked. Okay, that's what a census means, everyone. Now, most of the time, a census is not feasible, right? Especially a census of an entire nation, right? Because by the time, exactly, it's true. By the time someone tries to do a census in America, people are being born, people are dying, okay? Because it takes that long, all right? So what the way that you kind of get valid information about a population is you have to have a good sample. So a census is usually not a viable option, especially if you're talking about like all of the adults in the United States.
Not everybody does the census, right?
What do you mean?
Not everybody does it. I remember when we got it, we didn't do it.
Okay. I mean, it's helpful to do it so that way the state and the government can give more funds to your public schooling, your community centers, things like that. So I would recommend doing it. All right. I'm not going to force you to. Okay. Okay. Anyway, let's move forward. So, with populations, whenever we talk about knowing all of the data from a population, all right, knowing everything, we talk about parameters. And this is where I always think of to help myself with alliteration. All right, so we have population parameters, which you're going to see in this class, but usually never know. And then sample statistics. All right, so that's what we're going to focus on in this class, are the statistics that come from sampling. All right, and we've already done a lot of work with this. The way the course is structured is a little different than what you might see in other courses. We start with looking at analyzing data. That was like the first 8 chapters. All right, and now we've moved into how do we collect the data to then analyze. So these chapters are about how can we gather the information to then analyze the data. Okay? So the table at the bottom are the letters you need to know. We've used some of these. Remember mu and sigma? right? Remember, those are for parameters or models from a population. So these are the Greek letters, and these are the Latin letters. You should see that bar, which means, no, the average. The bar means the average. Okay? My personal favorite footnote in this book, if you want to read it, that's a footnote. It says pronounce P. Like pronounce the letter P. I just thought that was pretty good. No? Okay. Just me then. Okay, so now the last 10 minutes, I want to get into the type of samples we're going to learn how to run. All right, and tomorrow's activity will give you an even better idea of the difference between these. All right, so yes, it's going to be another made-up fake example. I'm so sorry that all my examples are not real, but it's a good lesson, a good activity to determine which one is which. So this is the most basic one. This is the one you just did with the blubbers. This is the simple random sample. Every blubber, every combination of blubbers had the same chance of being picked out of your 100 to be those 10. Okay, so without even knowing it, you've already run one simple random sample. Okay, or from now on, you can say SRS. That means simple random sample. And it is the simplest version. All right, if I wanted to do an SRS of this classroom, every single one of you would get a number, and I'd pick however many I wanted out of the total. Questions on the SRS? Okay, a couple of words up here you want to look at. Sampling frame. This is the list of all possible individuals or things that we could draw from. So our sampling frame for the blubbers was the 100 blubbers. Okay, and your sample was your 10. Sampling variability. Do you remember we went around the room and not everyone had the same thing? Some of us did, but most of us did not. That's called sampling variability. It's a good thing. All right, that is literally where the world of statistics comes from. Sampling variability. Okay, it doesn't mean you did something wrong compared to your partner. It just means you have a different sample. Okay, the next one, stratified sampling. Okay, I think the easiest way to think about for stratified is to think about going to a buffet. Has everyone been to a buffet before? Doesn't matter what kind. You've been to a buffet? You know how it works. Okay, when you go to a buffet, everything that's in the, and I don't know the name, what are like the platters, if you will, that has all the food in it? Okay, platters? I don't know. Anyway, if you know, let me know. Anyway, where all the food is in, okay, in the platters are homogeneous, all right? All the food in each platter is the same. And you go in and you take a little bit from each platter, right? Does everyone see it? Yes, that's how a buffet works?
Yes.
That's called stratified sampling. So every time I go to a buffet, I think, oh man, stratified. I do. Yeah, I'm like, oh, some of this, some of that. Well done. Stratified. Every time. And when I go back for seconds, then I go stratified squared. Now, that's the way I view stratified. Okay? Stratified sampling is you have homogeneous groups, and you take a little bit from each group. That's stratified.
What if you get what if you just get ice one? Yeah, like a lot of. At the end, we just get the ice like a mountain of chicken nuggets.
Okay. Now, this is where students get confused. Okay? So cluster. I'm going to see if I can take you one step from my buffet example. All right? I'm older than you, so I've been to more life events probably than some of you. Or I've been to more weddings, is what I'm talking about probably. All right? So some weddings I've been to have been buffet. All right? My wedding was a buffet. I guess our wedding was a buffet. I was there. Okay? She was there. Okay? Well, she's not there, but you know what I mean. Okay, so our wedding had buffet, which means that people got to have a little bit of each, stratified. Okay? I've been to other weddings where they put a plate down in front of you that has everything on it already. That's cluster sampling, where every single person has the same version, all right? And you just are selecting, oh, I'm going to go to that table and select all of them from that table. Or I'm going to go to table 6, get one from there, table 8, get one from there. It's all the same. So cluster sampling is where your groups are heterogeneous. The way I think of it is all my clusters are mini populations. Okay? All my clusters are mini populations, and you take a couple of clusters. All right? We'll go over the difference between that tomorrow. If you do anything where it combines more than one, it's called multi-stage. All right. So if you do a lot of times if you do stratified, you're going to do also an SRS within that. Okay. Okay. All right. Almost done. Last one. Last one. Systematic. Systematic. I always think about when I go fly and go to the airport. All right. Whenever I go through screening, security, I always think about systematic sampling because that's what they do when they randomly screen someone. All right. When they look at the customers coming through for the day, they'll randomly pick a customer and then go like every 17th customer is going to get screened, or every 1,200 person is going to be screened. All right. So whenever you see a sampling method that talks about every 4th person is being picked, that's systematic. All right. The key thing here is that you have to start with someone, and so you randomly pick the person to start with. So if I did a systematic sampling by going like in order like this, I still have to pick randomly to start with Diego. Now you go every 4th person. Okay? Everybody good about the difference between these? If you're not, we still got time to figure out the difference between all those sampling methods. Questions?